Okay, so Dash is out. People will connect and disconnect. Disturbance will be there. That's why people go and come in. But before the time, better log in. Okay. So anyway, I will start. So what is our topic in the morning? So what we discussed about OSI layers. 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Application layer dealing with the ports, application at a server, client, protocols, and their ports. So what is a request? What is a protocol? We already discussed. What is a protocol means what kind of request you are sending. Okay, you want a web page, or you want to download, or you want a remote connection, you want a mail, you want to send a mail, you want to receive a mail, you want an IP address, you want to receive an IP address, you want to send an IP address, you want to map the IP address. Okay, like that for authentication or remote sessions or any what kind of request will be understand by protocol only. What kind of request you are asking, so are giving. Okay, so what kind of data you are giving, what kind of request you are giving, what kind of response you are giving. That is important. Request and response. What kind of request you are giving, what kind of response you are giving. So based on that, you are using a protocols. Next, presentation layer is dealing with what kind of data it is. Convert the data into ASCII code and ASCII code to normal data format. Okay, that is we call as encoding and decoding, and compress the data, encrypt the data, and decrypt the data. Next is a session layer. Session layer is it will create a session when you are sending a request. It will create a session until you receive a reply from your destination. Till the time it will maintain the session. Once complete the transaction, it will then terminate the session. Okay, so also a session layer is also will take care of multiple sessions based on the requirement. Okay, multiple sessions. What is multiple sessions? So we'll see that one. See. I'm going to CMD. I'm ping to some IP address. So this is my router IP address. I'm ping to my router. I know already. So this is one session only. So ping is like I'm sending a ping request to router. Router giving a reply to me. Okay. I send a ping request. So then I got a reply, ping reply. So reply I got it. For example, this is one session. I started a session. Now finish the session. Session is completed. This is one session. But here, when I send a google.com, ping google.com, first I need IP address. So this is getting an IP address for google.com, one session. Sending a request to the google.com, it is another session, right? So, but both the things happening in a single section only. So multi sections are maintained by session layer. Okay, this is one session, this is another session, ping reply is another section, and getting an IP address of google.com is another session. Okay, so but it is happened with a single command or a single request only. So it means multiple sessions also it will maintain. So we no need to divide everything into separate way, like very simple way. Like you open a web page or you are sending a data or, like that. Okay. Next, here we should understand we have to start the transport layer, but you have to understand the data, whatever the data in a different layers. Okay, so either it is from application layer or presentation layer and session layer, the data is can be converted into different formats, right? Whatever the data you are using, the data is in a different format. Maybe it is in ASCII code format or encrypted format, maybe in a compressed format. Like whatever the data is in a certain different format, but nothing is added to your data. Nothing is added to your data. Data format is changing, but data is not adding to new data. Nothing is added to that one. Of course, session ID will be added. That is also inside of your data format only. In our networking, we call this one as a PDU. PDU. Okay. What is a PDU? Packet data unit. We cannot say packet, we cannot say data, we cannot say unit also. We have to say the whatever the layer data, whatever the data it is, whatever the format of data is it is, we have to call that one as a packet data unit only. And different names will there in a different format. Here it is actual converted data, whatever the data is there. Okay, so that PDU means whatever the format of that PDU will become to our transport layer. What happens in the transport layer? Okay, what happens in a transport layer? I think better 175. This is good. Okay, for example, I want to send a message. Hello, how are you? I want to send this message to some destination. I want to send this message to some place. Okay, so destination. I'm a source from A to B. I want to send hello, how are you? What happened at the receiving end? It is not getting output clearly. So it means, for example, I'm going to Notepad. Hello, how are you? So it's a beautiful message. So it's my what I don't habitual message. Okay. Okay. So here, this is my message. I send it. What happened while you are transmitting the data? Some data is missing. Some part of data, or maybe some data is missing.
Sir,
Yeah.
sir, recording.
Yeah. I'm recording. Recording.
Okay.
That is going
Sorry,
on.
sir.
Okay. Good. Remind me sometimes like that. Okay. Okay. I send a message to someone. What happened? Certain part of the message is missing. Certain part of message is like this. For example, think like this. What happened? Hell are you? Or a hell you? Sorry. What happened if, for example, not now? So, like you guys are a person send to his girlfriend. Hello, how are you? By mistake, what happened? The data is corrupted. Okay, data is corrupted. Now it is hell you. What happened? Breakup. Immediate breakup. Right? Okay. So what happens? So data can be corrupted. Either small part of the data or pure form of data is corrupted. So it's like this. Okay, or maybe like this. Okay. So some part of the data or complete data corrupted, or maybe anything will happens when data is transmitting. Due to this, due to this, due to this, the receiving end. So it will verify the data. At the receiving end, it verify the data. Data is correct data or corrupted data. Data is correct data or corrupted data. Okay. So at the receiving end, the machine is verify the data. If it is data is corrupted, if data is corrupted, what will happen? It drop the packet. It won't accept the packet. Okay. So just for fun only, I told like, what if it is not verifying the data? It is just display the data at user end. Okay, that is I told. But normally, in generally, system verify the data format and data is good, then it will give it to the next layers. If data is corrupted, you drop the packet. You drop the packet. Okay. Now what happened? I send once. Receiving end data is corrupted like this. Again, I will send the entire packet again. Entire packet I send. Now what happened at receiving end? It received like this. Okay. So maybe and next time I send it is at receiving end it received like this. So what happened? I'm keep on sending the messages and receiving end it is getting a corrupted. Max to max it is corrupted message will get it. Simple example: if data is in a big format, So when your transmission of data, big data from one place to another place is always difficult. Think like a big cart. If you have a very big cart, like yeah, not wide cart. I have a now recently I purchased a wardboard. Okay, the wardboard is like assembled wardboard. Okay, almost all I have three things, like three or four things are there. Almost all assembled things only. My table mate, I have two table mates. A small table that is also plastic, that is also assembled. So why it is? It is a very simple to transmit that one. Instead of sending a table which is fixed table, it is very difficult. Assembled, so we will understand which part is there, which part is missing, which part is we can able to replace, like that. Okay, so this is what I am trying to say. It is, so assemble means small part wise. If you are sending a data, so then we will understand which part is missing, which part is not there, which part is not there, like that. It is easy to transmit a small data compared to sending a huge amount of data at a time. Okay, so what your transport will do, it will divide the data into small parts, not like this. It depends upon the data, but for understanding only I'm telling this one. Okay, for understanding only I'm giving like this. So it divide the data into smaller parts. So minimum 64 bytes, minimum data size is 64 bytes, maximum data size is around 1500 bytes. Okay, it's maximum one single data maximum size is around 1500, is less than 1500 only, but 1500 bytes. Minimum is 64 bytes. So each data packet, if it is less than a 64, then it is called as a junk, so it won't transfer the data. Okay, data packet must be more than means one part we are saying, that part is a minimum 64. Okay, so it divide the data into small parts. This part dividing we call it as a segmenting. We call this one as a segmenting. We divide data into small parts called a segmenting. Okay, and also yes, we are divide a packet, but we divided the packet. Okay, that is very good. We divide a data into small packets, small parts. Okay, each part we call it as a segment, or the process we call it as a segmenting. Each part we call it as a segment. Each part we call it as a segment. The process we call it as a segmenting. Okay. Next, of course, I received a data. For example, I received a hello. Okay. I send these four packets. Okay. I send four packets to destination. At destination, what happened? Destination received hello or you. Only three packets received. Fourth packet is not received. So destination, this is a source and destination. Source and first, one, two, three, four parts. It's sent as a packet. One first packet, second packet, like. Here it is received. Second one is received. Fourth one is received. Third one is not received. I send everything, but third one is not received. Third one is not received. So what it will do, destination, understand carefully. It will send a acknowledgement. I received acknowledgement. I received one. I received two. I received four. And what it will do? Okay, destination not received one, two, four, but not three. Huh? Yeah, it is second one, right? It's okay. I'll change it pattern. Okay, destination received one, two, four only, not three. Okay, third one is not received. So destination will tell a source, I received one packet, I received second one, I received third one, like that. Okay, so source understand, okay, third packet is not received, it will send a third packet. It send a third packet. Now what happened? Here it is, hello, how you are. Okay, so what happened here? the pattern is changed. Okay, the pattern is changed. Of course, how to rebuild into the correct format? If you are giving a proper numbering system, so then we can able to rebuild entire thing. Okay, just for example, understand, you know, if you go to the printer, right? Okay, you go to you want to print a document, for example 5 pages document, he given of only 4 pages. How do you understand one page is missing? So if you put a number, how many pages are there, total number of pages, and which page is missing out of 5 pages you are printing, but you got only 4. It means one page is missing. You will understand one page is missing. How you understand? Based on number. But which page is missing? That is, you have to create numbering on each page. Numbering on each page and total numbering and each page. Like that, we will understand the printing, right? So, just for understanding only, I am telling it is actual format is not like this one. Actual format is not like this one. Just for our understanding only, I am telling this one. Okay. So, for example, if I put a 1 by 4, 2 by 4, 3 by 4, 4 by 4. For example, if I put a numbering and a sequence order, so what will happen? At a destination, I received 1, 2, 4, 3. So I can rearrange it what 3, 4 in a proper order. Okay. So you don't need to send same data again and again, because of you are sending a small parts only. Second one, which part not received by a destination, we can send that part only. I'm sending only third packet, I'm not sending all the packets. And next, I'm arranging all the packets in a one order and send to the next layer. So when I receive the packets, it is not in order. So I will arrange it the order. Once I receive all the packets, I will arrange all the packets in order and I will send to upper layers. So then again entire data will be reconstructed at upper layers, right? So this one we call it as a numbering and sequencing. We have to put a numbering on it and we have to do sequence. Okay, numbering and sequencing, we should do it on it. So this is the first part of uh, transport layer. Okay, so this is like you are sending a message, already I told. Okay, if you send a message, the entire message may not be received by your destination, so we have to do segmenting. Okay, the first one is segmenting, next one is numbering, and sequencing. So this is the letters are very big one. Okay, numbering and sequences. This is the main first role of your transport layer. Okay, next, we are using a lot of different protocols in your communication. So when you are communicating from source to destination, we use different protocols here. So one of the protocol like maybe HTTP DNS, FTP DNS, SSH DNS, or SMTP POP3 IMAP, SMTP POP3, or SMTP IMV4, SMTP DNS HTTP. Okay, so in a one single communication we use different type of protocols. So whenever you sending a packet and are receiving a packet, so in a total communication different type of um, protocols we use in a communication. Okay. Hmm. HTTP, FTP, HTTP SSH, HTTP SSL. So different combination of protocols we are using in a communication. These protocols and ports are divided into TCP type and UDP type. TCP type of protocols, UDP type of protocols are there. TCP type of protocol and UDP type of protocol are there. So, for example, HTTP comes under uh, um, TCP type of protocol. FTP TCP type of protocol. SMTP TCP type of protocol. TFTP TFTP UDP protocol. SNMP UDP type of protocol. DNS UDP type of protocol. DHCP UDP type of protocol. So here in our engineering also we have a lot of different opinions about TCP and UDP, but you see simply the protocol either it is TCP type or maybe UDP type or maybe a both. If you go to Wikipedia, you will get a big list of that one. For example, protocols and port numbers. See, you can see DNS. DNS is a 53 port number, and you can see TCP type and as well as UDP type also. Sometimes act like a TCP, UDP both it is there. DHCP UDP protocol, TFTP UDP protocol, HTTP protocol. So you can see this is enough. Okay, very good one. Okay, see 1024 well-known port numbers. This is registered port numbers and this is dynamic port numbers. DNS. SSH, TCP, UDP, TCP, UDP, FTP, only TCP, Telnet, TCP, TCP, UDP protocol, TFTP. This is NetBIOS, IMAP, SNMP, okay, like that. So some are pure form of TCP, some are not TCP, UDP combinations. So here we should remove DNS, DHCP, TFTP is a pure, not even a pure also. NTP, you can see NTP, Network Time Protocol. NTP is also UDP. Okay, so I will change. Okay, this is all as per that list. Again, if you go another list, it will go to change. Okay, so understand this is at either the protocol either TCP type or UDP type or a both will be there. Like a DNS, it is showing DHCP and DNS type protocol. Get it? So the protocol type is there. But what is the difference between TCP and UDP type of protocol? Normally, after completion of TCP example and UDP example, so we have to tell we have to tell examples. But I am telling example for understanding. Okay, next. So TCP is acknowledgement based. Okay, so acknowledgement based. What is this much? Not required. Acknowledgement based communication. Here in UDP, no acknowledgement, no acknowledgement. Okay, it is full. It is coming up to here. It is not a acknowledgement based protocol. So what is the acknowledgement based protocol? I have a source and a destination. So this is I am sending a packet. For example, I am sending a packet to destination. I send a packet to destination. Okay. Now, what will happen? I send a packet. Once destination received a packet, when destination received a packet, what it will do? It send a acknowledgement. Send a acknowledgement. So then source understand, destination received. Okay, so when I send a packet to the destination, so destination will send a acknowledgement to the source. Okay, so like this it keep on sending the thing. So what is the advantage of this? Just I'm a lazy little bit now. Okay, so I send a fourth packet, I didn't receive, I didn't send. Okay, so I didn't send a acknowledgement, so I didn't receive any ACK4. Okay, I didn't receive it. What happened? So source thing, it doesn't not received any source, doesn't not received any acknowledgement from the destination, so it think this packet is not received. Then what it will do, it send the packet again. Now the destination received the packet, now it will send acknowledgement, it send a acknowledgement, yeah, okay, I received now. Understand? If not received, if destination not received a packet, it will it won't send a acknowledgement to the source. And source thing destination not received a packet, so it will resend the packet again destination send a acknowledgement, so I received. If it is received by a destination, so it will give you acknowledgement. What is acknowledgement? Very simple. uh, you know when someone is speaking, if you said yes, no, giving reply, that is means acknowledgement based communication. You are acknowledging it. Earlier days, uh, we have a set exams like MSET examinations, gate examinations, okay, ISET examinations, so many OU set examination, AU set examinations, lot of examinations we are applying, including government jobs. We apply for IAS, IPS, both are same. Both are same means same exam only. IES, okay, group examination, IAS, like that. So we have to fill the form. Have to sorry, what happened? We have to fill the form. Once after filling the form, attach acknowledgement form also. Okay, so we are attaching acknowledgement. So you can go to the post office. If you pay 5 rupees or 6 rupees only acknowledgement, you have to pay 5 rupees extra. You will get an acknowledgement card. So attach a acknowledgement to the application form. What happened at receiving end? When they received your application, when they receive an application, they will send back your acknowledgement. They will send acknowledgement back to you. So what is the advantage of that one? You will know other person is received. You will know your application form is received by particular department. What are the department? It is the examination department received or university received. Nowadays everything is online. That's a different part. But very simple, right? Even if you pay online payment done, you will receive a transaction ID or some acknowledgement, you will get it, right? Payment is done. This is the payment, this is the transaction ID, you will get it, right? Anyway, you have to pay for Charan sir, right? So Charan sir means 70s. You're paying online only. You will receive a acknowledgement. You're sending your acknowledgement, sir. We paid. This is acknowledgement. So check it and add how much payment is be done. We show the payment receipt, right? Charan sir don't know how much you paid it. You have to show the receipt. So this much of payment we done. This is online transaction. Receipt is there. So then put it that in our details. So this is what I'm saying is, okay. So this is what I'm saying is sending and receiving based on the acknowledgement. What is an acknowledgement? I received. That is a acknowledgement telling to the source. So it is reliable connection. Next, how UDP works? No acknowledgement. I send a packet to destination. Destination received or not? I don't know. Someone came new, old, Mukesh, and someone asked out. So now I will be back. Okay. See, I send a packet. Other side received or not? I don't mind. I will keep sending the packets. Okay. For example, I sent three packets. Destination side it is received. Okay. It's received all the packets. But fourth packet is not received. What I will do? Will send a fifth packet. I don't know whether it is the fourth packet is received or not. I don't know. Even if it is not received, I don't know. The destination is not received. Destination is not received. So this is how UDP works. So we didn't write what is TCP, what is UDP also. Transmission Control Protocol, the user datagram protocol. What is TCP? Transmission Control Protocol, user datagram protocol. Uh, okay, I will go to TCP. What is the TCP? Transmission Control Protocol. You have to keep on reading. Size is not enough, so no problem. Instead of that one, I will put a TCP separately. Okay. And what is a UDP? User Datagram Protocol. Of course, TCP, UDP. There are itself protocols. There are protocols, and they are also having a port number. TCP has a port number. UDP has a port number, and there are also protocols only. Okay. User Datagram Protocol. So TCP depends upon acknowledgement, UDP no acknowledgement. Because of it is depends upon the acknowledgement. Because of TCP depends upon the acknowledgement, and we are make sure that destination is received a packet. We are make sure in TCP make sure destination received a packet. That is called a reliable connection. So reliable network or reliable communications or a connection. Reliable communication, reliable connection. So we can say anything. So reliable communication, I put it. This is a non-reliable. Non-reliable. This is reliable. This is non-reliable communication because we don't know destination is received or not. Okay, reliable, non-reliable. So TCP is called connected oriented word. Okay, this is connectionless. This is connection oriented and connectionless protocols. Okay, so the connection oriented and connectionless protocols. Yeah, just yeah. Okay. Can anybody give example like connection oriented? Which one is wired network? Which one is wireless network? Is TCP is a wired network or UDP is wired network? Which one is wired? Which one is wireless? Wi-Fi. Which one is Wi-Fi? Which one is wired network? Anyone? Because that is very important. Because we learn something
TCP
in
is wired network.
TCP is
Wired.
wired network, and this is Wi-Fi or wireless, right? Absolutely no. That's why I'm asking question that in a college days people are keep on telling this is wired network, this is wireless network. Already I told I believe in that one. I've written an examination, I passed in the examination. Still I don't understand why people are telling like that. Like this. What we know, same thing, right? So I'm just checking myself. I'm learning same like that, or everybody learning like that. Okay, it is not belongs to connected or connectionless. It's a connected oriented means we are getting acknowledgement. You give an answer, right? I ask a question, you given an answer, it means connected. Connected means when I tell something, you said either yes, no, or some answer, it means you are giving an acknowledgement. You said we received information, that is called connected. Connectionless, I speaking something, no one is replying. I don't know whether you received or not. Sometimes, of course, now people are interactive, but certain classes I will keep on speaking. No one is giving reply. Even I don't know whether people are connected or not. Okay. One day my connection is disconnected. My side only. Almost I took a 5 to 10 minutes extra class also. Okay. I just checked it. Everybody is disconnected. Not everybody. My side. My internet is disconnected. Even I don't mind about it. I keep on speaking. So that is like connectionless. Connectionless means I don't mind whether you are understand, not understand, you're replying, not replying. I don't mind it. I will keep on speaking. That is connectionless. Connected oriented or connection oriented. Connected oriented or connection oriented. So what is this meaning? It is acknowledgement based communication. Do you received? Do you understand? Are you got this information? So this is connected oriented. Like reply, we got it in a ping comment. That is connected oriented. Okay, very good. Okay, so that's just to point out, it is not belongs to wired or wireless or Wi-Fi kind of stuff. It is a TCP. Anything. If you are using I'm using Wi-Fi, but I'm using HTTP, right? Understand? I'm using Wi-Fi network, but I'm using HTTP. HTTP is a TCP/IP. It's a connected oriented. I should use wired only, right? So people now maybe I don't know. From last 10, 15 years, anybody lecturers are change their motto to teach properly. Mhm. Teach properly means first understand and learn. That should be improved. Uh, okay, first of all, we should give a proper information, correct information at least, somewhat information. Okay, correct one. So that is not giving. Okay, from by our colleges. I don't know. I'm not telling all the colleges or all lecturers, but most of them. in my time, that is very less people are teaching. Some are very good teachers are there. Okay, so they got good jobs and they left. Okay, so like that, people should learn. People should see the real time, at least real time or textbooks, videos. Now material is more available. Earlier giving wrong information because of material is less available. Okay, if this is about transport layer, segmenting, numbering, sequencing, and TCP type thing. So what it will do, it multiplex and demultiplex. Multiplexing, demultiplexing means opposite of multiplexing thing. So to do it, like what it will do, it take a TCP and put all the in your communication what protocols you are using. The protocol is a combination of TCP and UDP. It put all the TCP things into TCP box and UDP in a UDP box. It will create a two boxes like this, TCP and UDP things. So what it will do? So it put all the what are the communication while you are communicating, you are using, for example, TCP, HTTP protocol, and also you are using DNS, and also you are using something like SMTP, and also you are using NTP. Okay, so similarly, like in one single communication, you are using some TCP protocols and as well as UDP protocols. What it will do, it will create a box. Okay, all TCP protocols in the TCP box, all UDP in a UDP box, all TCP things in TCP box, all UDP in a UDP box. So why it is doing like this, like to make it more easy communication instead of protocols mixing up with other data, it's separating the protocols and put it into separate. Okay, next, these also do flow control. This flow control is also different name is there. One is flow control, next one is windowing. Okay, transport layer also doing flow control, and also flow control also called as a windowing. There's two different technologies. What is this flow control? I am sending a packets continuously. So first packet, I send a first packet, second packet, third packet, fourth packet, sixth packet. I send to destination. Destination receive first packet, second packet, third packet, fourth packet only. Okay, so what it will tell? So it will give you an acknowledgement. Normally, we received an acknowledgement ACK for first one, second one, third one, and fourth one only. I received acknowledgement for a one. So what happened? I didn't receive 5 and 4. I have to send 5 and 4 and other things. For example, I'm sending 5, 4, 7, 8, 9, 10, for example. So I received 5, 6, 7, 8 only. And I send an acknowledgement for a 5, 6, 7, 8 only. So what is meaning? Here it is, I send a 6 packets and the destination said I received 4 packets. I send again 6 packets, destination say I received 4 packets. What is that meaning? Destination at a destination end only 4 packets can receive. Okay, destination can receive 4 packets only. For example, I am my source. My source PC, okay, source PC is 1 Gbps connection. Okay, my destination PC, okay, is 100 Mbps connection. Sorry. So 1 Gbps means per second 1 gigabit I can able to send it. 1 gigabit of data I can able to send it. At a destination, it cannot receive 1 gigabit per second. It will receive only 100 Mbps only. So almost like a 10 percentage. Okay. Total data 10% only it will can able to receive. So for example, if I send a 100 packets, at destination can receive 10 packets only. For example, just for example, understanding. So what happened? Mismatching of speed is occurs. Mismatching of speed is occurs. Okay. So what our TCP/IP will do? It estimate. Okay, mismatching of packet is there. It estimate how much destination can able to receive a data. It will estimate that one and it will send the packet like that only. So 9 and 10 is not received. Now I am adding 11 and 12 also. Okay, I'm sending only 5 packets, then easily 9, 10 and 11 and 12 received by destination, and so then they will send an acknowledgement based on that one only. Okay, so estimate destination capacity of receiving a packet, based on that send a packet. So not only because of different speed of source and destinations, also traffic. Also traffic. If traffic is more at the destination one, so we can't receive, right? So for example, you went to a shop, for example, it is a closing time. Okay, for example, if you are going to shop at the closing time, what happened? More traffic in it. Okay, for example, you went to DMart. You want to DMart. Tomorrow is a Saturday. Day after tomorrow is a Sunday. So just for example, Saturday evening or Sunday afternoon or evening, you go. It's a lot of traffic is there. Lot of people. So everything is busy. Its flow is very high. The billing time will take time. Okay. So because of traffic at the single point, also it cannot able to receive the thing. So not only a mismatch of speed, also depends upon the traffic at a destination, um, also there. Okay, so based on the traffic, so it will estimate how much data can able to received by destination PC at present, and based on that it will send a packet. So this is called a flow control. Now we are go back to the transport layer again. So what transport layer will do? It's segmenting. So it segment the data. Okay, so what is the segmenting the data? Shop chop data into small parts or pieces. Okay, so that is called a segmenting. Okay, what is a numbering and sequence? It's a assign a sequence number to segment. It means piece piece of data. The piece what we are making, that piece are a parts of a data. Okay, next TCP UDP, transmission control protocol, user datagram protocol. TCP type of ports, TCP type of port protocols are there, UDP type of protocols are there, and TCP. Okay, is a acknowledgement based communication, and UDP means no acknowledgement based, like HTTP acknowledgement based, TFTP no acknowledgement here. Next, uh, acknowledgement based communication means when a source send a data, one source send a packet to the destination, destination give acknowledgement to the source, so then so source understand destination received the packet. When we are not received an acknowledgement, it means destination is not received the packet, or something is happened to the packet. Again we have to send the packet till we reach the acknowledgement. And UDP is send one pack, it's UDP, it will send a packet to the destination, and it won't verify whether it is reached or not, just send a packet. So because of that one, TCP is a reliable connection or a reliable communication, and UDP is a non-reliable communication. TCP called as a connected oriented because of acknowledgement, and it is a connectionless because of no acknowledgement. And what is this TCP UDP differences? Why we learn? So because of our transport layer also do uh, what it will do. So all the TCP protocols kept in a TCP side, and all UDP the UDP protocols in a UDP side, like that it will multiplex. It multiplex like a TCP, under TCP all the TCP protocols inside, and like that is it will do. So it will multiplex the protocols into TCP and UDP side only. Of course, these are also protocols, and they are also having a port numbers. And transport layer also do flow control, or that is also there is a two techniques: flow control technique, windowing technique. I'm not going to discuss what is this technique, what is this technique. If you're interested, you can search in internet or go through books. But here there is a few conditions, like because of the traffic or maybe a mismatch of data transmission and receive speeds. Okay, the data completely not received by at the destination, like this. For example, I'm sending a 6 packets at a destination, it receive only 4 packets. So it means the destination can able to receive only 4 packets at this time, so we have to send 4 packets, so we can avoid packet dropping. So see, here it is 5 and 6 is not received, it means 5 and 6 is dropped. Again I have to send a 5 and 6. So instead of sending a packets again and again, so we can send a packets based on the receiving end capacity. So that is what transport layer it is. And only one part is there in a transport layer, already told, that is packet data unit. In a whatever we are there. So what happened, there is a TCP header will be added to your PDU, your packet data unit. So again combine the, we call it as a PDU. So the first one we call it as a header. We are designing, so I have to choose. Actually if I choose to draw in a that is enough. Actually we have to put a box. Okay, so this is your transport header. This is a transport header, and this is a normal data. So this combination, we call this one as a segment. Call this one as a segment. Okay, So TCP header is added to your normal data. What is a TCP header? TCP header contains TCP UDP information and acknowledgement number, segmenting number, sequencing number, everything will be mentioned in TCP header only. So this TCP header is adding to your PDU and it will become segment. This segment is forward to next layer is called network layer. Okay, so this is your. So what is this segment? Segment itself is a PDU. Segment itself, this total we called as a PDU, but this is the PDU from previous layers. This PDU from previous layer, we are adding a extra data here that is called a TCP header. This is a transport header is TCP. So what is the name of the part? It is segment. Guys, I am repeating each and everything. Don't think I'm making you bore. Okay, I think so. I'm making you more bore. Okay, but it is very important. That's why I don't have a choice also. In network layer, so network layer receive a segment. Network layer received segment. So in a network layer, what happened? There is a two type of protocols are there. One is routed protocols. Another one is routing protocols. Okay, these things will be added. What is a routed protocols? IP address, it means IPv4 or IPv6. But actually IPv6 format is different, but IP address either it is IPv4 or IPv6, so mainly IP. Next, IP addresses are IPX, SPX. So different type of addressing schemas are there, na? So different type of addressing Apple talk. So different type of routed protocols are there. Anything is it's like a IP address type of addressing things on it. Next, routing protocols is like adding a routing information like RIP, EIGRP, OSPF, of course BGP, anything. So many type of different routing protocols are there. Okay, so these are a basic routing just for a naming purpose only. So in network layer, it will add in network layer is contains routed protocols and routing protocols. If you are doing a routing concept is there, then it will involve this thing. If no, then it is involve routed protocols only. So here in this one, what it will add? It will add source IP, destination IP address when you are communicating. So you need a source IP and destination IP address to your segment. We received all the segment, right? So source IP and destination IP is added to your segment. This combinedly we call it as a network header. This is combinedly we call it as a network header. This is segment. Okay, this is a segment. This combinedly we call this one as a network header. NH. Okay, so this is network header segment and source IP, destination IP is added here. Of course, if you are using any routing protocols, then routing protocols will be added into network header only. So this combination we call it as a actually packet. Actually network packet we call here only. The packet contains source IP and destination IP only. So this packet is further forward to, okay, which layer it is? Data link layer. This is sent to data link layer. So this is your network layer. Very simple. Transport layer is the only big one. Okay. So here is a data link layer. In a data link layer, there is a two layers are there again, LLC and MAC. LLC first and MAC is next. Here still no confusion what it is, no confusion. LLC and MAC. LLC is a logical link control. LLC means logical link control. Okay, so logical link control. So this is very useful when you are using a WAN connectivity time. But directly okay, so it is what is that, a logical link control. So this is also dealing with the different protocols like a frame relay. Frame relay is like a switching protocol. Okay, frame relay, PPP, HDLC. Okay, MLP or not. Yeah, this is a mobile location protocol. No, 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 not this one. That's okay. So leave it. No MLP. So don't put anything else. Okay, certain WAN protocols is dealing with it one, and mostly it will interact with the higher layers only, because of the MAC layer is pure hardware layer, and upper layers are almost like a software layers only. So to make more communication between these two things also LLC will support. And another one is whenever using a WAN protocols, so it support the WAN protocols also. Next, MAC address. What is a MAC? Media access control. And already I told how to check the MAC address itself. So MAC address is also called as, okay, MAC address is also called as physical address, hardware address, and unique address. Okay, it is given by or assigned by manufacturers. It is 48 bit. No, you can also tell parallelly 48 bit, 12 hexadecimal. How to check it? Get MAC in a CMD or ipconfig slash all. And already I showed in a GUI wise also, ncpa.cpl and right click status details also. You can check it. I given another option also. So this is a data link layer. What happened in a data link layer? So we are adding source MAC address and destination MAC address to your packet, and also it is adding CRC. What it is adding? Source MAC address and destination MAC address and CRC to the packet. So the first one, this is part we call it as a data header. Data header. So here I'm giving like this. Then this is the packet, natural packet it is from your previous layer, and this one is data tail. That is head. This is tail. That's it. Okay. So this is a starting. This is ending. So the packet is added with the source MAC address, destination MAC address, and CRC. This we call it as a frame. Okay, this frame is sent to physical layer. So, but we are missing here one is CRC. What is CRC? Anybody?
Cyclic redundancy check.
Very good. Cyclic redundancy check. What is this cyclic redundancy check? Is a error detecting code commonly used in digital networks and storage devices to detect accidental changes to raw data. So it is nothing but an algorithm. CRC is an algorithm. It verify your data. Okay, it verify your data is any changes occurred. Okay, so you're transmitting a data. For example, you are copying a data from your system to your pen drive. After you are connecting, like you given a data to your friend through pen drive. He connected the pen drive to his system and open the data, and data is corrupted. Why? Because normally data is while transferring some one place to another place, or maybe because of some other changes, data may corrupted. So what is the use of the CRC? It will check your data is correct or corrupted. Data is same data is there or corrupted data is there. If data is corrupted, then sometimes it can able to repair it, sometimes we can't able to repair the data. So we can say data is corrupted. First important is data is corrupted or not. If data is not corrupted, we can use it. If data is corrupted, then either it is small repair or a big repair. Based on that, it will do automatically. And CRC generates a code value. Based on that code value, it calculate your entire data. It generate a code value from your data only, and it will calculate the data with that code value. So it will do it. If you want to see the CRC check, go to any rar files like this. See, rar files. Can you see rar? WinRAR files are there. No? Just go to that one because it's archive plus compression. You can see CRC32. See, this is the CRC value of this data. Okay, CRC value of this data. Okay, cyclic redundancy check. Very good. Now physical layer. So last layer. Okay, the physical. So for everything, I am not putting layer part, but when you spell it is put a layer. So then you will understand more. Okay, so it's a physical layer. So what is a physical layer? The frame received to the physical layer, and it convert the frame into bit stream. Convert the frame into bit stream, and bit stream to a signal to signal. What is the signal? Either electrical signal or a light signal, light wave, or a radio wave, or radio signal, anything. So depends upon your NIC. Depends upon your NIC. So which layer you are using. So what kind of NIC you are using? Are you using a Wi-Fi? Okay. Are you using a Wi-Fi thing or maybe Ethernet, normal Ethernet, or maybe OFC? Okay. So depends upon that, it will convert into that one. So this is your second part of OSI layer. And I'm going to starting. Okay. So just for a thing, OSI layer, open system interconnect. It's a reference model. Okay. And OSI layer having 7 layers: application, presentation, session, transport, network, data link layer, and physical layer. Application layer dealing with protocols and their port numbers and client and server side application. Next, presentation dealing with conversion of data from normal data to ASCII code, which we call it as encoding, decoding, and also it will do compression and decompression. And the presentation layer do encryption and decryption data. Session layer will create a session, maintain session, and terminate session, and also it will maintain multiple sessions also. We call the data as a packet data unit here. So transport layer do segmenting. Segmenting means dividing a big data into small parts, and we are also assigning numbers and sequences. Okay, I'm not writing here how much minimum size. Actually it is 64 bytes. In segment each part is a 64 minimum. So 64 and higher only it will be there, otherwise it is not valid. And maximum is 15, around 1500 bytes, not more than 1500 bytes. Okay, almost like a 1350 something around is there. Okay, numbering and sequencing. So once we divide the data, it a number and put a sequence order also. Next, TCP IP, TCP UDP, sorry, TCP UDP multiplexing and demultiplexing is there. In a TCP we have a TCP type of protocols, UDP protocols, put it in a separate box. Okay, separate box means TCP, all TCP protocols under TCP layer and all UDP protocols under UDP layer in a transport layer. Okay, TCP is acknowledgements based protocols. UDP protocols are not acknowledgement based protocols. What is acknowledgement? When you send a packet and at the receiving we received it, and we'll send the destination received. Once destination receive a packet, it send an acknowledgement to source, then source understand destination is received. If destination source is not received acknowledgement, so source think destination is not received a packet, then it will send the packet again. In no acknowledgement base, source send a packet to the destination. Whether destination received a packet or not, we don't verify it. That's why we call it as a UDP, as a non-reliable network or a non-reliable communication. UDP is a reliable communication. And also we put a two names called a connection oriented for TCP IP, TCP, and UDP is a connectionless. So TCP UDP are not a different thing. Both are protocols only. They have a port numbers, but protocols, either TCP type of protocols or a UDP type of protocols, or both is there. So it's a combining multiplexing and demultiplexing of a protocols into TCP wise or UDP wise. And transport layer also do flow control and windowing, estimate the speed of receiving at the destination side. Based on that, it will send the packets. Okay, and a transport layer will add a TCP header to our packet data unit. So then the combined thing, the TCP header and this one combinedly we called as a segment. So the segment is forward to network layer. In a net layer is added with a source IP and destination IP to our segment. So the total packet we call it as a packet, and that packet is sent to the data link layer. Data link layer has a two layers, LLC and media access control. So what is a MAC address? Is a media access control, also called as physical address, hardware address, unique address. Mainly we have to understand MAC address, physical address and hardware address are same names, which is assigned by address is assigned by manufacturer only. It is a not a logical address, it's a physical address only. Okay, we cannot change it. It's a very unique in nature. Okay, 48 bit, it's a 48 bit size in a binary, and 12 hexadecimal represented in 12 hexadecimal. So how to verify? Get MAC or IP config all, or go to nc run ncpa.ctl. Okay, right click on adapter, whatever the adapter, like you can see I put a Ethernet or local area network, anything, any name. Okay, right click status and details. So like this also you can see it. So what is a data link layer will do? Data link layer adding a extra thing like a source MAC address, destination MAC address, and CRC as a data tail. So the combination packet like a source MAC address, destination MAC address, your packet, and the CRC, the combine we call as a frame. The frame is sent to the physical layer. The physical layer is convert your frame data into bit stream. The bit stream further convert into a signal. Either it is electrical signal or light wave or radio wave, depends upon what kind of NIC you are using. And here in the data link layer, CRC means cyclic redundancy check. It is an algorithm to verify your data, which data is safe or a data is corrupted. That's it.